Alright, this recording is going to help us understand the use of negative and zero exponents. The basic idea comes from how to reduce fractions. If we want to talk about reducing fractions, like 6 over 10, we always try to rewrite as 2 times 3, basically finding their prime factorization. 10 is 2 times 5. But now we realize that we're multiplying times a 2 on the bottom and a 2 on the top. Then I can take them and I can reduce those 2's, because 2 divided by 2 is 1. 1 times anything can disappear. That's our identity rule. We don't need those 2's. And basically we're left with just 3 over 5. Now, at the same time, we can take that and use that rule for for variables. X times X times X times X. And there's our fifth one, right? That's what X to the fifth really means. And X to the third does the same thing. So if I reduce one at a time, one from the top, one from the bottom each time, I'm left with just X times X, or X squared. We also had the division rule, or the quotient of powers rule, that said if I'm dividing with equal bases, X to the fifth, X to the third, that I can subtract the top exponent minus the bottom one, and 5 minus 3 also gets me directly to X squared. Now the real trouble comes in when the bottom exponent is larger than the top exponent or equal to, such as we have on the second example there. Because now if I subtract, I get 3 minus 5 is X to the negative 2. And now how do I interpret a negative exponent? Well, if we think about it with our reducing rule, right, that was X times X times X over 5 of them. Which means, again, I can reduce one at a time, 3 from the top, 3 from the bottom, and that leaves me with X squared in the denominator. And since all the top is gone, basically, clean that up a little bit. Basically, there's nothing left on the top again except for that 1. Which means that any negative exponent is really the reciprocal. You can move that to the denominator as a positive exponent. And now we have a simplified statement without any negative exponents. The same thing goes for equivalence. If that's X times X times X, both top and bottom, then if I reduce, I've basically gotten rid of all of the parts. All I have left is a 1 on the top and a 1 on the bottom, or a 1. Well, if I do my subtraction rule, that's a 3 minus 3, it becomes X to the 0, which means that any zero exponent will always be equal to 1. You've reduced both the top and the bottom completely. So we get our two rules. Zero exponents, essentially anything to the 0 power equals 1. And for negative exponents, they make reciprocals. That also goes for any negative exponents in the denominator. If we had 1 over, and I took this a to the negative 1, I made that 1 over a to the n, the positive n. Well, remember, we can multiply by the reciprocal. On both top and bottom. There should be a 1 down here. But I'm going to also do that on the top. Which means we end up with a to the n positive exponent over, canceling here, a 1. So basically it flips up top and becomes just a to the n. Essentially, any negative exponent in the numerator can move to the denominator. Any negative exponent in the denominator moves to the numerator, but as a positive exponent then. So if we had things like the 4 examples on the screen here, first thing I'm going to do is make 5 to the negative 2, then a to the negative 2, but because they're both negative exponents, I can move them both into the denominator. and we will end up with 1 over 5 squared a squared. Same thing goes with the numbers over here. I can take my y and I'm going to move it up top, y to the first in the numerator. X to the third is also to a negative exponent, so I'm going to move it to the numerator. Now be careful, often people confuse this. 9 is not to the negative third. 9 is not to a negative exponent. It needs to stay in the denominator. And that would be our final answer. Let's move directly down here. 5 to the negative 1 then is going to move to the denominator as a 5 to the first. 0 is also going to move to the denominator, 0 to the first. And again, if there's nothing left up top, that's a 1. But now wait a minute, that means this is 1 over 0. And remember, we can't divide by 0, so we call that undefined. If 0 is ever to a negative exponent, basically we just moved 0 to the denominator, and that's not a good thing. Now that's different though than x to the 0. Remember, x to the 0 goes to our 0 exponent rule. So x to the 0 can become 1, and y to the negative 1/6 becomes 1 over y to the 6th. And 1 over y to the 6th times 1 is 1 over y to the 6th. So that's how we can use our negative exponent rules. Now, if they get a little bit larger, oops, sorry, I forgot, big rule, got to make sure. Never leave a simplified answer with a negative exponent. That means it's not simplified yet. Try these couple of problems. I'll pause the video for about 5 to 10 seconds. If you want to pause the video as well, try the problems out, and then recontinue. I'll have the answers up for you. See you in a bit. Alright, here are those answers for you. In the first one, I just took my negative 1 exponent up here, and at first I used my power to a power property and moved it in to each part. So x to the second times negative 1 became negative 2, negative 4 to the negative 1. Remember, the negative, right, is just a negative, so that's not a big deal. So I can kind of consider this as negative 4 to the negative 1 there. And then 2 to the negative 1 on the bottom. And negative 1 times negative 1 again, the exponent power to a power, became x to the positive 1, which means that x needs to stay in the denominator down here. The 2 to the negative 1, though, moved up top. The negative 4 technically moved to the bottom. Remember, it doesn't really matter where I draw that negative. I can put it either spot. It's just a negative fraction at that point. And x to the negative 2, again, also moved to the denominator. 2 over 4 becomes a half. X times x squared is x cubed, and you've got your answer. Same thing goes on the second one. I took my negative 3 and I applied it to all 3 pieces of that term, the coefficient, the x, and the y. 3 times negative 3 is negative 9, negative 8, and negative 3 was 24, which means y to the 24 stays on top. The other two with the negative exponents, both 2 and x, are going to move to the bottom. And then I just need to simplify. 2 to the third technically is 8. It gives me a final simplified answer. I hope that helps you with negative exponents and 0 exponents. If you have any questions, make sure you see your teacher. Otherwise, have a great day.